Recent studies on dark streaks on the surface of Mars indicate that, contrary to previous beliefs, they have a dry origin. Years ago, the discovery of dark streaks on the surface of the red planet created a lot of buzz. These streaks seem to represent water flowing from rocks and the walls of craters on Mars. Scientists endeavored to understand what these lines were. Some believed they were seasonal streaks of briny ice that gradually melted with the onset of Mars's weak summer. However, a new study refutes this theory. Our understanding of Mars, its past, and its potential for ancient habitation depends on how we understand its water. Mars is now a cold and dry planet, but it was once warm and moist. A key question is what happened to the vast amounts of water in its oceans. When scientists began observing the dark lines on Mars that looked like seasonal water flows, this discovery sparked excitement. Could these streaks be signs of ancient waters leaking from underground reserves? Could these reserves be suitable habitats for simple life? The Martian streaks, known as recurring slope lineae, RSL, appear and disappear at similar locations and can extend hundreds of meters along slopes. According to Universe Today, the recent study examined Martian streaks from a new perspective and concluded that RSL and other similar streaks do not have a water origin. This research focuses on two related phenomena: RSLs, which appear and disappear seasonally, and slope streaks, which may last for years or even decades. Researchers state that slope streaks are dark-colored structures that spontaneously form on Mars's slopes and fade over years to decades. Previously, the formation of these streaks, both RSL and longer ones, had been attributed to aqueous processes, implying that liquid water or significant transient brines might exist on the surface of Mars, a topic that could greatly impact the planet's current habitability. Previous research suggested various origins for these streaks, including subsurface brine springs, seasonal melting of briny ice, Martian earthquakes, and even wind. It had also been noted that RSLs appear more in the summer of the southern hemisphere, while slope streaks tend to form more in the fall and winter of the northern hemisphere. The researchers write, as of today, it is unclear whether RSL and slope streaks are two different manifestations of a single process or two completely distinct phenomena. Understanding the origins of these streaks is crucial. If their origin is water, this means that the water cycle on Mars is more active than previously thought. This will affect our understanding of the climate, weather, surface evolution of Mars, and even the possibility of life. Furthermore, if water or brine exists on the surface of Mars, it raises significant concerns about planetary protection, i.e., preventing contamination of Mars by Earth spacecraft, and necessitates much greater caution in explorer missions. The researchers compiled a comprehensive database of 500,000 streaks for their analysis. They identified a total of 13,026 bright streaks and 484,019 dark streaks. These streaks have a variety of shapes and are divided into two types, bright and dark. There is no clear boundary between bright and dark streaks, but generally, the dark streaks are considered newer and younger, while the bright ones are older. After analyzing the data, the researchers reached some conclusions. They wrote, "Our studies reject three previously proposed mechanisms for dry streak formation. Dust devils, rockfalls, and thermal cycles do not play a significant role in creating these streaks on a global scale." The researchers also found that none of the scenarios related to the formation of the streaks through water aligned with the observed data. These streaks do not prefer any specific direction on slopes, which calls into question the theory of carbon dioxide frost as a triggering factor. Instead, dry formation scenarios were supported. The authors state, "We identified three meaningful global statistical relationships that support dry formation hypotheses for slope streaks. Based on the findings, the streaks are generally closer to areas of recent meteorite impacts, the surface wind speed in those regions is above average, and in the winter of the northern hemisphere, which coincides with the increased formation of streaks, the dust deposition rate in those areas is estimated to be higher than normal."